Consider the following formula. Which of the following statements is true for this formula? To solve this question, we're going to need to graph it, but before we graph, we're going to need to label our axes in terms of Q and P. Normally, our x-axis is our cause that affects our y-axis. So if we look at our answer choices, we can see that P in this case is the cause that's always affecting Q. So that means we can label our axes as P is our x-axis and Q is our y-axis. And now there's only one more step we need to do, and that is simplifying our equation because we have a lot of denominators here and we want to get rid of those to make our lives easier. So if I write Q over 4 equals P over 6 minus 0.5. We're going to multiply everything by the least common denominator, which would be 4 times 6, which is 24. So we'll take everything and multiply it by 24. Our first term, these, we're going to pull out the greatest common factor, which is 4, and that will leave us with 6 on top. So we will have 6 times Q is equal to, here again pulling out our greatest common factor, we're left with 4, so we'll have 4p minus 0.5 is the same thing as 1/2, so what's 1/2 of 24? That would be 12. And now we have an easier equation to work with, so now we can start to find our x and y intercepts. First, our x-intercept is when y equals 0, or in this case, when q equals 0. So let's start with 6 times 0 instead of 6 times q equals 4p minus 12. 6 times 0 would just give us 0 equals 4p minus 12. Let's do the opposite operation. Add 12 to both sides. These will cancel. 12 equals 4p, and then 4 is being multiplied to p, so the opposite there is to divide both sides by 4. 12 divided by 4 will give us 3 equals p, so our first coordinate point is going to be 3, 0. Then we'll need to find our y-intercept, or where x equals 0. In this case, where p equals 0. So again, I'll rewrite my formula. 6q equals 4 times 0 instead of 4 times p minus 12. Here, we'll have 6q equals 4 times 0 is just 0, so this is completely gone, leaving us with negative 12 on the right side. 6 times q, or 6 is being multiplied to q, so the opposite is division to both sides. These will cancel, leaving us with q equals negative 12 divided by 6 is negative 2, or the point 0, negative 2. Here I have used our intercepts in order to graph our function so that we can visualize it and find our correct answer. If we take a look at our x-intercept, we can see that everything greater than that intercept has positive q values. So we can say when p is greater than 3, q is going to be positive. And then the opposite is true. When we're less than this positive 3p value, we are going to have negative q values. So when p is less than 3, q is negative. And now we can go through our answer choices and find what is true. A says if p is less than 6, 6 would be over here, q is positive. Well, 6 would be right about here on our graph. Less than is going to the left, and it would be positive for a little bit, but once we pass our intercept, all of the q values will become negative, which will make A incorrect. B says if p is less than 3, q is positive. Well, according to this statement right here, when p is less than 3, q is negative, not positive, so that will make B also incorrect. C says if p is less than 6, let's bring back 6. Oops, sorry. 3, 4, 5, 1 more over. If p is less than 6, q is negative. Again, this is only partially true because some of these values are positive and then the rest of the values are negative. So C is incorrect. By process of elimination, it's D, but I will show you why D is correct. If p is greater than 6, q is positive. This is true because everything that's greater than 3 is positive, and 6 is a number greater than 3, so this point right here at p equals 6 will also have positive values continuing into infinity, making D our correct answer.